logarithm and indices. I've given us the laws of indices and how to use it in solving problem. Today and at this time, I want to look at laws of logarithms. The laws of logarithms. It has relation with laws of indices, and this is the reason why the two topics are married together in learning related to engineering mathematics, because some of the problems we solve, they have the basis that are rooted in what? In indices and logarithms. This is the reason why the two topics are preceding topics in engineering mathematics that one has to get the understanding. The first law states, if you have log A plus log B, it means log A times B. Anything log is in base 10. So, e.g., if I have log 2 plus log 3, this implies log 2 times 3, and the final result will be what? Log 6. That's the first law. The second law says, that's the additive law. Log A minus log B says it is equal to log A divided by log B. This implies that, for example, if I have log 6 minus log 3, my result will be log 6 divided by 3, and that will be what? Log 2 as a result. The third law says, if I have log A base A, the result is equal to 1, which is the same as if I have a question log 2 base 2, the answer is 1. So any number whose base and the what? Whose the log and the base, they are the same thing, is equal to 1. Number 4 says, if I have log A base B, I can change it to become log A over log B. That is, for example, if I have log 2 base 3, it can become log 2 over log 3. Number 5, if I have log A raised to the power of x base B, it can become x log A base B. I've thrown the power of the log to the back. That is a rule. For example, if I have log 5 raised to the power of 2 base 3, it can become 2 log 5 base 3 as the final result. 6. If I have log A raised to the power of x base B raised to the power of y, it can become x over y log A base B. Because what? Initially, at log 4, at root 4, there is a power, at log 5, there is a power for the base, but the power is 1, which makes this to be what? X over 1, and X over 1 is the X. The same thing applies to here, that I have 5 raised to the power of 2, the base is 3, having power of 1, and 2 over 1 is the same thing as 2. That's why it wasn't reflected here. But in this, because there is a specific value for the power of the base, I could see it that the power of the what? Of the log is divided by the power of the base and x over y. For example, if I have log 5 raised to the power of 2 base 3 raised to the power of 7, it will become 2 over 7 log 5 base 3 as a result. Log 7 says that if I have log A base B, I can change it to become 1 over log B base A. And this, for example, if I have log 5 base 2, it can become 1 over log 2 base 5. This is provable if you want to check to confirm if it is true. If truly log A base B is equal to 1 over log B base A, I can say 1 over log B base A is equal to 1 divided by log B base A. From the rule, if I recall that log A base A is equal to 1, therefore 1 is equal to what? 1 divided by log B base A could be said to be log A divided by what? Log B. Divided by log A. Log A base A divided by log B base B. And this will give us from the law that we have actually stated in terms of log 4. If you have A base B, it can become log A over log B. So we can say this can also be log A over log A divided by log B over log B, log A. And according to simplification rule, if we have the division, to change it to multiplication, we reciprocate. Reciprocating means the numerator of the value of the fraction at the back of the division. The numerator becomes denominator and denominator becomes numerator. So we can have it to be what? Log A over log A multiplied by log A over what? Over log B. And from here, we can cancel out this, become 1, 1. And that will be what? Log A over log B. And finally, it becomes log A is B that we have returned to where we started. That proves that it is what? It is continuable as regards to that. The log 8 tells us that if I have B equal to A raised to the power of n, if I want to introduce log, since this is the index base will be used to log both sides in order to do what? To take it from a normal what? Equation to log. How do I mean? I will say log P base A is equal to what? Log A raised to the power of n base A. I'm trying to log both sides. And with that, I can see to be what? That log P base A is equal to what? N log A base A. I should recall that what? Log A base A is equal to 1. So therefore, log P base A is equal to what? N times 1. And finally, log P base A is equal to what? Is equal to N. As regard to this. This gives us the idea of introducing what? How we can introduce log into an equation. For example, e.g., if I have P is equal to 5n, I can turn this to log. I know that it will change to what? Log P base 5 is equal to what? Is equal to n. I've used the rule, this rule, to do what? To convert this to log. And lastly, which is the 9th law, we should know that log 1 is equal to 0. Anytime we solve a problem and the result is that we are having log 1 as the final thing, we should know the final answer is equal to 0. These are the 9 laws that governs the law of indices.